Okay, so welcome to my tutorial about recursion. So what is recursion? Recursion is calling a method by itself over and over until it cannot call itself anymore. There are two parts of a recursive formula. The first is known as the base case, which every single recursive program has to have. The base case is the first number and it has to be there for a recursive program to work. The second part is just the code. So what am I going to teach? I'm going to teach you how to write a Java recursive program, and at the end I'll give you a recap of what I talked about in this presentation. So let's get started. So in this presentation I'll be teaching you how to create a Fibonacci sequence program that uses recursion. The Fibonacci sequence is basically just a sum of two preceding numbers which starts at 1. The base case in the Fibonacci sequence would be 1 because the sequence starts at 1. The Fibonacci sequence goes like 1, 1, 2, 3, 5, 8, 13, 21, etc. So now let's go over the logic for the Fibonacci sequence. So then we know that Java always starts at 0. So if we want the first Fibonacci number, then we have to get the position at 0. If we want the second Fibonacci number, then the position has to be equal to 1. So we know that at positions with 0 and 1, which is the first and second number, then the Fibonacci number is 1. So then if n is equal to 0, 1, then return 1. If it is not 0, 1, the return is sum of the two preceding terms. So now let's get to start coding. So we're going to create two classes for the program. There's going to be a class that starts with a Fibonacci number at a given position, and another class that's going to be the main driver class. The class called Fib is going to do all the work and it's going to calculate the Fibonacci number at a certain point, while the class called Fib test is the main driver program. So here's what your classes should look like right now, just two empty classes. So now let's code the logic for the Fib class. So we're going to create a method called Fib1 which takes a value of n. So as we went over previously, if you want the first Fibonacci number, then we have to call n equals 0. So if n equals 0 or n equals 1, then return 1 because the first two Fibonacci numbers are 1. Now we want to return the sum of the two preceding terms, which is n minus 1 and n minus 2. So here's the class code for the Fib test class. So as you can tell, there it's pretty much self-explanatory and I don't have to explain anything. So now let's go over what is happening. So we know that the base case is 1 and the second number is also 1. So as I mentioned earlier, Java always starts at 0. So if you want the first number, then it will be at position 0 to Java. So now let's say you want the third number. Then you have to call n equals 2 because at position 0, that will give you the first number. If it's at position 1, it will give you the second number. So if you want the third number, you have to call n equals 2. So the method Fib1 calls for the sum of n minus 1 and n minus 2. Well, 2 minus 1 is 1, and 2 minus 2 is 0. So Java wants to know the sum of the numbers at positions 1 and 0. So from the if statement, we know that at positions 1 and 0, then you have to return 1. So then 1 plus 1 is 2. So the third Fibonacci number is going to be 2. So now let's say you want the fourth Fibonacci number. That will be when n equals 3. So the method Fib1 calls for the sum of n minus 1 and n minus 2 again. So 3 minus 1 is equal to 2, and 3 minus 2 equals 1. So then, now we have to get the sum of the numbers at positions 2 and 1. Well, from before we calculated at position 2, which is the third number, the Fibonacci number was 2. And at position 1, the number is 1. So the fourth Fibonacci number is 3, because 2 plus 1 equals 3. Now let's see when to calculate the fifth Fibonacci number. So n equals 4. The method Fib1 calls for the sum of the position 3 and 2. Well, earlier we calculated at position 3, which is the fourth number, and the Fibonacci number is 3. And at position 2, which we calculated in the previous slide, which is the third number, the number was 2. So the sum of positions 3 and 2 is going to be 3 plus 2, which is 5. So the fifth Fibonacci number is 5. So basically all we did was we called the method Fib1 over and over again, and we used what we knew before to find the sum of the two terms. So here's the recap. Recursion is basically when the method calls itself over and over again until it ends. There are two parts of recursion, the base case and the main code. And the Fibonacci sequence is a sequence that starts at 1, that is the sum of its two preceding terms. The end.